You're about to see over 10 million galaxies. This just released footage from the brand new Vera Rubin Observatory is made up of over 1,000 images of the night sky.
Space has a way of making humanity feel small. Every time we build a more powerful telescope, we expect answers. Instead, we find new mysteries. That may be exactly what is happening now. Deep in the darkness, the Vera Rubin Telescope has captured something that scientists are struggling to ignore. At first, it looked ordinary. Then the data came back, and what researchers saw raised a chilling possibility. The universe may be far stranger than we ever imagined. The asteroid that should not exist. For decades, astronomers believed they understood how asteroids behave. They drift slowly through the dark. They tumble gently as gravity nudges them along. They follow the same predictable rules that every textbook on Earth has been printing for the last 100 years. Asteroids are supposed to be the boring background characters of the solar system, the quiet rocks that nobody worries about, the simple stones that occasionally cross our path and then disappear back into the void. Then, on a single ordinary night in early 2026, the Vera Rubin Observatory in Chile pointed its enormous camera at a patch of sky in the main asteroid belt between Mars and Jupiter. The data came back. Scientists began processing it, and what they found made several physicists genuinely uncomfortable, because the numbers on their screens did not match anything humanity had ever recorded before. There was an object in the dataset that, by every law of physics we currently understand, should not be there at all.
A silent giant has been spotted in deep space.
The asteroid 2025 MN45 is the fastest spinning large asteroid detected so far.
Not in one piece. Anyway, the object has a name now. They call it 2025 MN45. It measures roughly 710 meters across, about the size of a small mountain. That part is normal enough. Plenty of asteroids that size exist in the belt. The terrifying part is what the asteroid is doing. This thing spins, and not in the slow, sleepy way most large asteroids spin. It completes one full rotation every 1 minute and 53 seconds. Read that again, slowly, and let it sink in for a second. A mountain in space, rotating faster than the second hand on a clock can chase. By every model we have, an object that big should not be able to spin that fast. The centrifugal force should be tearing rocks off its surface and flinging them into space like a cosmic blender running at full speed. Every researcher who has ever modeled asteroid behavior would tell you this asteroid should already be in pieces somewhere, but it is not. It is holding together against forces that should be destroying it. Something deep inside that mountain is stronger than our science can currently explain to anyone. Sarah Greenstreet from the University of Washington led the research that announced this discovery in January of 2026. She told reporters the asteroid must be made of material with extraordinarily high internal strength, some unknown substance binding it together against gravity and rotation. The DOE Associate Director, Regina Rameka, put it more carefully, but the meaning was the same. Discoveries like this one are pushing the boundaries of what scientists thought was even possible to observe. Greenstreet also said something more haunting at the press briefing. She mentioned that in some of the very first test images taken with the Vera Rubin Observatory, the team was already breaking records before science operations had officially begun. The same study found 19 other ultra-fast rotating asteroids hiding in plain sight, including one spinning even faster than MN45, 19 of them, in data that was supposed to be just a warm-up before the real work started. Now imagine what is coming next. If the telescope is finding record-breaking objects during its early commissioning phase, what happens when it spends the next 10 years staring at the sky every single night? How many impossible things are spinning, drifting, or hiding out there right now, simply because no machine on Earth has ever had the eyes to find them? Because that mountain-sized asteroid was only the second strangest thing Rubin had captured by early 2026. Something else was already waiting in the data, and it was far bigger and far older. The river of dead stars around Messier 61. There is a galaxy called Messier 61. It floats roughly 55 million light-years away from Earth, a beautiful spiral wrapped in dust and starlight, surrounded by other galaxies in the Virgo cluster. Astronomers have studied this galaxy for decades. They have pointed Hubble at it. They have pointed every major ground-based telescope at it. They have photographed it, measured it, written papers about it, and felt fairly confident they understood its basic story. Then Rubin took a single image, and everything they thought they knew about Messier 61 began to unravel in a single evening. In November of 2025, a team led by Aaron Romanowski from San Jose State University published the first peer-reviewed scientific paper based on Rubin's early data. They found something wrapped around Messier 61 that nobody had ever noticed before. A faint, ghostly river of stars stretching across space like a half-buried scar. The river is roughly 163,000 light-years long and 10,000 light-years wide. To put that number into something your brain can hold, our entire Milky Way galaxy is about 100,000 light-years across. This stream of stars is bigger than the galaxy we live in, and every previous telescope on Earth had completely missed it. Romanowski explained what this ghostly thing really is. Long ago, a smaller galaxy got too close to Messier 61. The bigger galaxy's gravity grabbed it, stretched it, and slowly ate it. The river of stars we see today is the corpse of that smaller galaxy. Its remains pulled into a long, thin trail that orbits Messier 61 like a memory that refuses to fade. Romanowski said this discovery shows how much is still unknown about the life histories of galaxies. He called it the hidden universe, shaping the realms that we can see. Read that line one more time. The hidden universe, shaping the realms that we can see. That single phrase is exactly what Rubin was built to find. Not just the bright, the obvious, the famous objects, but the faint, the forgotten, the invisible structures that secretly control everything else. Because galaxies are not just collections of stars, they are surrounded by invisible halos of dark matter, the mysterious substance that Vera Rubin herself proved must exist back in the 1970s. And streams of dead stars, like the one around Messier 61, are how we can finally map that dark matter. The way the stream bends, kinks, and ripples tells us where invisible chunks of dark matter sit nearby, tugging on the dead stars like ghosts pulling on strings. This is the reason everyone working on Rubin is so quietly excited right now. Every galaxy out there might have streams like this one, hundreds of them, maybe thousands. And every stream is a window into the dark side of the cosmos that we have never been able to study before. Rubin is going to find them all over the next 10 years. Each one will be another clue. Each one will be another piece of the puzzle that Vera Rubin spent her whole life trying to solve and never lived to see finished. And while astronomers were still recovering from the Messier 61 discovery, a different team in Chile noticed something stranger sitting inside Rubin's archive. Something the telescope had captured weeks earlier, completely by accident, without anyone realizing what it was at the time. The visitor from another star. The story of this discovery begins on the 1st of July, 2025. A comet from another solar system was officially announced to the world after being spotted by a robotic telescope network called ATLAS. The astronomy community lit up immediately. Telescopes around the world began rushing to study it because interstellar visitors are almost impossibly rare. Only 2 had ever been confirmed before in human history: Oumuamua in 2017 and Borisov in 2019. This new one would become the 3rd, and they named it 3I Atlas. But 10 days after the announcement, something strange happened in Chile. A small group of researchers decided to go back through the Vera Rubin Observatory's archive of test images, just to see if the telescope had accidentally captured the comet before the official discovery. They expected to find nothing. They found everything. There it was, the comet, glowing softly in pictures taken on the 21st of June, 10 full days before any human being on Earth even knew it existed. Rubin had been quietly watching the visitor from another star while the rest of the world had no idea anything unusual was happening. The comet was already releasing a cloud of dust when Rubin caught it. Scientists measured that cloud growing from about 13,000 kilometers wide on the 21st of June to almost 19,000 kilometers by the 2nd of July. The telescope had captured the entire awakening of an alien comet, frame by frame, while the data simply sat in storage waiting for somebody to look. Pedro Bernardinelli from the University of Washington said something that gave many readers chills. He said, "This is a direct demonstration that Rubin is no longer in the future. It is the present. The machine sees things before humans do. If its software had been fully online just 3 weeks earlier, that comet would not be called 3I Atlas today. It would be called 3I Rubin. And that is the warning sign hidden in this whole story. We are no longer the ones discovering the universe first. The telescope is. Which makes the next question impossible to ignore. What else has Rubin already seen that no human has noticed yet? The answer involves a single morning in Washington, D.C., and the largest telescope unveiling event in modern history. The day astronomers stopped breathing. The morning of the 23rd of June, 2025, was unlike any morning the astronomy world had ever experienced. The location was the National Academy of Sciences building in Washington, D.C. Inside, journalists, scientists, and government officials packed shoulder to shoulder into a single room. Outside, more than 350 watch parties around the world gathered in living rooms, planetariums, and university halls. Everyone was waiting for the same thing: the first official images from a telescope that had taken more than 2 decades to build and roughly $800 million to finish. At 11 o'clock in the morning, the screens came alive, and the room went silent. Galaxies, millions of them, spilling across the screen like grains of sand on a beach nobody could ever finish counting. Some were blue and young, bursting with newborn stars. Others were red and ancient, holding secrets older than our planet. Some were crashing into each other in slow motion, locked in cosmic collisions that began before dinosaurs ever walked the Earth. And this single image, this one frozen moment, contained roughly 10 million of these galaxies inside it. The team gave the image a poetic name: the Cosmic Treasure Chest. It captured the southern Virgo cluster, the closest enormous gathering of galaxies to our own Milky Way. To make this image, the telescope took 1,185 separate exposures across 7 nights, totaling about 10.5 hours of staring. Astronomer Yusra Al-Sayyad from Princeton, one of the lead data management scientists, said the moment the image appeared on the screen, she could not believe it had finally come. Years of waiting collapsed into one stunning second. The second image they unveiled was even more emotional in some ways. It showed 2 famous nebulas, the Trifid and the Lagoon, glowing in pink and gold a few thousand light-years from Earth. These are nurseries where new stars are being born right now, in real time, as you read these words. The image was built from 678 separate exposures, around 7 hours of observation. But what made everyone in the room gasp was not only the beauty, it was the scale. Hubble, the famous space telescope, can only see 1% of the moon's surface in a single image. Rubin captures 40 full moons at once. To display one of its photos at full resolution on a screen, you would need 400 high-definition televisions stitched together. The director of construction, Zeljko Ivičić, said something simple but heavy at the press conference. He said the seemingly empty black pockets of space between stars, the parts of the sky you see with your naked eye and assume are nothing, are transformed in Rubin's images into glittering tapestries full of secrets. That word, transformed, kept echoing through the science community afterward. Because what Rubin does is not just take prettier pictures. It rewrites what we thought emptiness even meant. It tells us the sky is not quiet. It never was. We just could not see well enough to notice. And then came the third image of the morning, the one that genuinely scared some people in the audience because it was not beautiful at all. It was a swarm, and the numbers attached to that swarm broke something in the way humans understand our place in the solar system. 2,000 new worlds in 10 hours. Every single asteroid detection center on Earth, every space agency, every observatory hunting for cosmic rocks comes together each year in a quiet global effort to map our cosmic neighborhood Together, with all their combined power and patience, they typically find around 20,000 new asteroids in 12 months. That is the standard. That is the speed at which human knowledge moves when it comes to mapping our solar system. That is how fast we used to be. Until Rubin came along and made the previous record feel almost laughably slow. In a single stretch of testing, Rubin showed what one telescope could do in just 10 hours. 2,104 brand new asteroids. Not over a year, not over a month. Just 10 hours of staring patiently at the sky. 7 of those asteroids were what scientists call near-Earth objects, meaning their orbits bring them close to our planet. None of the 7 were dangerous, thankfully, but the larger point is impossible to ignore. The telescope found more than 10% of an entire year's worth of asteroid discoveries in less time than a single workday at the office. And it was just warming up. The team had barely begun calibrating the system. By April of 2026, Rubin had submitted more than 11,000 new asteroids to the Minor Planet Center, the official global registry of every known object in the solar system. The telescope had also refined the orbits of more than 80,000 previously known asteroids, including some that had been lost in space for years because no instrument on Earth could find them again. Among those new discoveries were 380 trans-Neptunian objects, frozen worlds floating out beyond the orbit of Neptune in the dark. There were also 33 brand new near-Earth asteroids that no human eye had ever seen before. All of this happened in about a year and a half of only partial operation, while the telescope was technically still in commissioning. 2 other asteroids found in that early data, called 2025 LS2 and 2025 EMIC 348, were tracked on orbits so stretched out that they reach up to 1,000 astronomical units away from the Sun at their farthest point. For comparison, Pluto sits about 40 units away. These objects are sailing in the dark fringes of our solar system, in places no telescope has ever properly seen before, drifting through a region of space that humanity has only theorized about. Kevin Napier from the Center for Astrophysics said something that gave many researchers goosebumps when they read it. He said these objects could tell us whether a hidden 9th planet still lurks somewhere out there in the cold beyond Pluto. The Planet 9 theory, the long-whispered idea that an unseen world larger than Earth might be orbiting our Sun in the deep dark, just got a brand new tool to hunt it down. But to understand why this single telescope can do what no other instrument in history has ever done, we have to talk about the woman whose name is written across the front of the dome. And her story is far more painful than most people realize. The woman they almost forgot. Vera Rubin was born in 1928 in Philadelphia. As a young woman, she applied to Princeton University to study astronomy. Princeton rejected her, not because she was unqualified, because she was a woman. Their astronomy department did not accept women until 1975, so she went to Cornell instead, and then to Georgetown for her doctorate, fighting for every opportunity along the way. Even the doors she did manage to walk through had been deliberately shut to women before her. In 1965, she became the first woman officially allowed to observe at Palomar Observatory in California, home of the famous 200-inch Hale telescope. When she arrived, she discovered there was no bathroom for women anywhere on the property. It had been a deliberate exclusion tactic for years to keep women out, so Vera took matters into her own hands. She taped a paper skirt onto the stick figure on the men's room door and told the staff, "Now, you have a ladies' room." Then she got back to work. Her research with a colleague named Kent Ford changed astronomy forever. They measured how stars moved in spiral galaxies, starting with our neighbor Andromeda.
So this instrument behind me is the 84-inch telescope at Kitt Peak. Vera Rubin started using it in 1968 when she started making measurements of the Andromeda galaxy.
And then expanding to more than 60 other galaxies. What they found made no sense. Stars at the edges of galaxies were moving just as fast as stars near the center. By the laws of gravity, that should be impossible. Stars on the outside should be moving slower, like outer planets orbiting our Sun, unless something invisible was holding them in place. That invisible something turned out to be dark matter. We still do not know what it is made of. We have never directly detected its particles. but we know it exists because Vera Rubin proved it. She showed that roughly 5 to 10 times more mass exists in every galaxy than what we can see. Most of our universe is hidden from us, and she handed humanity the first real map of where to look. She never won the Nobel Prize. Many physicists believe this was one of the greatest oversights in the history of science. She died on the 25th of December, 2016, at the age of 88, never having received the world's highest scientific honor. Then, in 2019, the United States Congress passed a bill to rename the telescope being built in Chile after her. The Vera Rubin Observatory became the first national observatory in the United States named after a woman. Her 3 sons, Alan, David, and Carl, all scientists themselves, said in a public statement that they were pleased because this was a great way to honor their mother's achievements and her lifelong work for equal rights for women in science. On the 8th of January, 2026, the family visited the completed observatory in Chile for a private tour. They stood in the dome where her name now lives, looking at the machine built to finish the work she started. And that machine, the one carrying her name and her dream, is more bizarre than most people realize. The way it actually works is almost impossible to believe when you see it explained. The machine that should not exist. The heart of the Vera Rubin Observatory is a telescope called the Simony Survey Telescope. Most large telescopes on Earth use 2 mirrors to gather and focus light. Rubin uses 3. The primary mirror stretches 8.4 meters across, which already places it among the biggest single mirrors ever built for astronomy. But here is the strange part that almost nobody talks about. The primary mirror and the tertiary mirror, the third mirror in the system, are actually polished into one single piece of glass. One monolithic block carved with extraordinary precision into 2 separate optical surfaces. Nothing else like it exists anywhere on Earth. Engineers had to invent brand new techniques just to make the design possible in the first place. The camera that catches the light from those mirrors is the largest digital camera ever built in the history of humanity. It weighs more than 3,000 pounds, about the size of a small family car parked at the end of the telescope. It contains 3.2 billion pixels arranged across 189 separate sensors, each one tested and calibrated by hand before installation. Its lens is the largest astronomical lens ever made, 1.5 meters across, polished to perfection. Inside the camera body, the sensors are cooled to 100 degrees below zero in Celsius to keep them silent and sensitive. To switch between color filters, the camera uses a robotic arm that swaps in a new filter in about 2 minutes, all without human intervention. The whole telescope moves faster than any large telescope before it in history. The full structure weighs 220 tons. It is built on a 16-meter-wide pier of concrete sunk directly into the bedrock of the mountain, carefully dug out without using a single explosive charge, so vibrations would not damage the precision optics. When the telescope needs to look at a new spot in the sky, it can swing 3.5 degrees in about 2 seconds and settle to a precision better than a fraction of an arcsecond in another 3 seconds. There is even an active optics system with 156 tiny actuators pressing gently against the back of the primary mirror in real time, flexing the glass by microscopic amounts to correct for gravity, wind, and temperature changes. The mirror is essentially alive, breathing and adjusting itself thousands of times a night to stay perfectly shaped. Every night, Rubin observes the sky. It produces about 20 terabytes of raw data. Over the next 10 years of full operation, the project will generate roughly 500 petabytes of processed data, an amount of information so massive it would have been unimaginable to scientists just a few decades ago. To handle this flood, engineers built a dedicated network from Chile to California through a 100 gigabit per second fiber connection. Within 60 to 120 seconds after the shutter closes in Chile, the entire world's astronomy community can receive an alert about anything new or unusual in that image. On the night of the 24th of February, 2026, Rubin sent its very first batch of real alerts to the global astronomy network. 800,000 alerts in a single night, all flagged and processed in real time. But the same moment Rubin opened its eyes to the universe, dark forces here on Earth were trying to shut its funding down. And that political fight has just begun in ways nobody quite expected. The threat that could blind the greatest telescope ever built.
Previous all-sky surveys have taken years, months and even weeks to complete one survey of the sky. This telescope's going to do it.
In the same week that Rubin unveiled its first images to the world, something quietly horrifying was happening behind closed doors in Washington, D.C. The current administration's proposed budget for the next fiscal year recommended cutting the National Science Foundation by 56.9%, from around $9 billion down to about $3.9 billion. A cut of $5.2 billion in a single year, gutting the agency that funds most American scientific research, including Rubin itself. Imagine spending more than 2 decades building the most powerful sky survey machine in human history, only to watch the country that paid for it consider turning off the lights the moment it finally starts working. For Rubin specifically, the proposed operations budget was $32 million. That is roughly 20% less than what the project had been preparing for over the past few years. At the press conference on the 23rd of June, when journalists tried to ask about the budget cuts, the moderators cut them off almost instantly. They said, "Thank you, we will not take budget or policy questions, only science questions." The science was triumph, the funding was disaster, and nobody on stage was allowed to talk about it openly, even though everyone in the room knew exactly what was happening behind the curtain that morning. The same proposed budget would dramatically reduce or shut down other observatories in Chile and Hawaii, including parts of Gemini, Kitt Peak, and Cerro Tololo. Some sites would be forced to close entirely. The LIGO gravitational wave detector would lose almost 40% of its funding, with one of its 2 locations potentially shutting down for good. American astronomy, at the very moment of its greatest single triumph, was being told to do far more with much, much less. It felt cruel to many of the scientists in the room that day. There is another threat, too, a quieter one. Above Cerro Pachon, where Rubin sits, thousands of communication satellites now streak across the sky every night. Starlink, OneWeb, Project Kuiper, and others have launched mega-constellations of small satellites that reflect sunlight as they cross overhead. Each one leaves a bright streak in any image taken from the ground. Simulations show that if these constellations grow to 40,000 satellites in the coming years, about 1 in 10 Rubin images will contain at least one satellite trail. The team is developing software to mask these trails, but every streak adds noise and makes faint objects harder to see. The night sky, the same one humans have looked up at for 100,000 years, is no longer fully ours. And yet, despite all of this, the telescope keeps working. Every 3 nights, the sky changes. Every night, hundreds of thousands of alerts go out to the world. Every week, new asteroids are added to the catalog. What do you think? Is Rubin about to change everything we know about the universe? Or are we about to be drowned in more questions than we can ever answer? Let me know in the comments below.